Hello and welcome to SudoKanard. We're here to solve this cross-sum Sudoku by Polish author Krystian Świderski for Sudoku Grand Prix. It was featured in the latest round. It was worth 87 points, which is quite a lot. And I solved it during the contest, but it took me a huge amount of time, much more than Killer Sudoku, that was more than 100 points worth. But I think that I overlooked one of the rules when I solved it, which might explain that I missed some of the deductions. So the special rule is that whenever you have such a cross, the sum is the same on both diagonals. And all such sums have been given, which is a very important rule. I'm not sure I remembered when I solved it. And I didn't solve it for quite a while, so I absolutely don't know where to start. I'm seeing those 8s, which means there is an 8 in here. So this part seems to be quite constrained. Let's have a look. So here we have a sum with an 8, so it will be at least a 9. So it could be 8 plus 1, let's say 8 and 1 on one diagonal, and for example 4, 5 on the other diagonal. Or it could be 1, 2, 4, 6, it could be 8, 1 and 3, 6. So there's a lot that could happen in here. I don't think this is the right place to start. Where can we go next? 9. What about 9? Well, 9 could probably be here. Let's say 9 and 1 with 4 and 6. Or it could be there, which wouldn't break anything. This seems to be pretty constrained, to be honest. And actually we can deduce the parity of this, because if you sum those 4 digits, you take a certain quantity twice, and likewise here, so that we get an even number by summing those and those. And what I have done, well, here we have 16, so the sum of all those digits is 29, and this plus that is 29 plus this, so that this is an odd digit. But this was probably much trouble for nothing, a lot of trouble for nothing. Perhaps I could focus this, I'm not sure. The given digits, perhaps? Oh, yes, the given digits. We can place a 7 here. Well, now that's a place to start. So there are lots of possibilities here. 1, 2, 3, 4, 5, 8. But I'm certain that not all of them will work. For example, if you try 8, that's a sum of 15. We would need 6 and 9 here. That's not a possibility. If we try 5, then it works with 4 and 8. If I try 4, it will work with 3 and 8. If I try 2, it will work with 1 and 8 or 4. 5 with 6, it could work with 2 and 8. Well, actually, none of those can be left out at this point. That's really not interesting. But there is a 7 in here. There is a 7 in here. Not sure what to do with that. There is a 1 in here, so there's not. We don't have a 1 in those, which is not so restrictive. What am I doing next? I'm really not seeing anything. Oh, actually, given digits, that's a 6. Now that's a place to start. This plus that is this plus that. So this has to be 2 units more than that. So what can we do? 1 and 3, no. 2 and 4, no. 3, 5, 4, 6, 7 and 9, that doesn't work. What did I do? 4, 4, 6, 5, 7, 5 and 7. 5 here and 7 there. 7, I said it works. 6, 8, no. 7, 9. So that's the only possibility. So that was the place to start. I've been missing a digit single since the beginning. Now this plus that is 5 plus that, so there's a difference of 4. This here is 4 more than that. So 1, 2, 3, 7 doesn't work, 4, 8 doesn't work. So the only possibility is 5 and 9. Now this 6 goes down there, and those digits here are from 3, 4, 8. Now we're talking. That's not 8. That's not 8, so this is from 3, 4, 6. And that's interesting here. This is from 2 and 6. Now that's really interesting. 1, 2, and 6 there. So there is the 3 somewhere. So what could we have? We could have 7, 3 on some diagonal and 2, 8 on the other one. That would work. Or 7 could be paired with an even digit. It wouldn't be paired with the 8. So 7 is not with 8. And that's interesting because now we know that 7 is on some diagonal and 8 is on the other one, so that the other 2 digits will be consecutive as well. So this is actually the only possibility. I couldn't have 6 into the mix. I couldn't have 8 plus 6. I couldn't have 7 plus 6. 8 wouldn't be paired with anything. So that's the 6 here. And we have 7 and 3 on some diagonal, and 2 and 8 on the other one. So those are from 2, 7, 8, and those are from 2, 3, and 8. So the 3 is in there. That's not a 3. I'm removing this. So 2 and 8 on some diagonal, 3 and 7 on the other one. I should have a look at this part as well. So here we have an even sum. That's odd. Plus that's odd. So this has to be even. 4, 8. So there is the 9 in there. And 9 is necessarily paired with the 1. If I try 9 here, then those two must have a difference of 8. That doesn't work. So that's 9. Those two sum to 10. They have to be 2 and 8. And that's the 4. So we don't have the 2 in here. We don't have the 8 there. Seven is somewhere in here. Perhaps I should have a look at what happens here, or maybe there. I'm not sure about that. perhaps here. I'm really not sure where to look. Perhaps we should ponder all options here regarding what goes there. I'm not too confident about that either. Actually, one of them seems to be very constrained. If I try the 3, 8, 7, 2, those two must be consecutive. That is not so constrained. Actually, let's look at this. It couldn't be 1, 2, 2, 3, or 3, 4, or 4, 5. It could be, no, it couldn't be 5, 6. Actually, none of those work. Couldn't be 5, 6. Couldn't be 6, 7. Could be, no, none of those work. So this is actually the 3 there, 2, 7, 8. And those have a difference of 5. Namely, this here is 5 over this one. So 1 and 6 doesn't work. Only 4 and 9 works. So there is no 4 in here. This is from 6, 8. So 2 and 4 are excluded now. What could we have? We could have 1, 7 with 3, 4, with 3, 5, sorry. Or we could have 5, 7 with 4 and 8. So 1, 7 with 3 here and 3 here and 5 there. Or 5, 7 with 8 there and 4 here, which means that this is a 3, 4 pair. That's a 6, that's an 8. Here we need 1, 3, and 5. Actually, 8 can only be here. So that this is 4 and this is 5. This is 3. Here we get 1 and 2. That's the 1. Here we need 3 and 5. Perhaps there is something. Yes, there is something about the negative rule. No, there's nothing with the negative rule here. No over there. No here. So the negative rule doesn't give me anything in this part of the grid. 3 and 4. This is from 1. Where do I look? This part looks more promising, I think. 6, 7, 9. So that's not 7. That's not 9. Here I need 3, 4, 5. That's not 3. So let's ponder what is happening here. The difference between this and that can't be more than 3. And we know that the difference here is the same. You know, if you to go from there to there, you need to add 4. That's the same here. So from here to here, we add at most 3. So it's the same here. So 9 doesn't work here. That's the 9. So now here we have a difference of 1. So here we also have a difference of 1. So that 4 is not here. 4 is in there. Still not using the negative rule. Is it really useful anywhere? So we don't know the order here, so we don't know the order there. 3, 4, this is from 1 and 5. 1, 3, 4, 5. So this is from 1 and 3. 3, 4, 5. Let's pencil mark this. This row would need 1, 2, 4, 5. Wow, that's not very interesting. There's a 6 up there. Not sure what to do with that. Can 9 be here? If 9 is here, then we need a sum of 10 or 12. But with those digits here out of the way, we can't have the other diagonal summing to 10 or 12. So 9 has to be here. This is a 2. That's a 3, 4 pair. Three, 4 pairs, so that 3 and 4 are here actually on this column. This is from 1, 5. That's a 3, that's a 4. Those are from 1, 2, and 5, but they need to be consecutive. This is 1 less than that, so that's a 1, that's a 2, that's a 5. This is 2, this is 1. And here those are 8 and 6, so this is 8, this is 6. There's a difference of 2. This is 2 more than that. So 5 doesn't work here. This is 3 or 5. And this is 1 or 5. The difference here is 2, so the difference here must be 2, so that this is 3. So that's 5, that's 1. And this is 2 more than that. That's 4, that's 2. That's not the 4. 4 is here. This 5, well, this is disambiguated. So this is 1 more than that, so this has to be 1 more than that. And actually this 6 could disambiguate this part. Here I need 7 and 5. Here I need 2 and 9. That's the 2. Here I need 1 and 9. Here I need 6 and 7, and that's 8, and that's 4. So that's really a beautiful puzzle. I lost quite some time on really not seeing naked singles, which is always a little sad when you're solving on the clock. And I never used the negative rule. So the negative rule was not needed. I don't know that it helped anywhere in the solve, so I really never needed it. So perhaps there were shortcuts with the negative rule, but I really never had to use it. So this is it. So anyway, that was really a smooth solving path for this puzzle, like all puzzles by Krystian Świderski in this round, which was a remarkable round, somewhat difficult, but remarkable round anyway. Thanks for watching this video. See you soon on SudoKanard.